This is SpaceTime, Series 28, Episode 121, for broadcast on the 8th of October 2025. Coming up on SpaceTime, the complex chemistry in the oceans of the ice moon Enceladus, the Dream Chaser spaceplane set for another delay, it now won't fly until at least next year, and NASA says its new optical deep space laser communications project has exceeded all its technical goals. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Scientists have discovered new complex organic molecules spewing from Saturn's ice moon Enceladus. The findings, reported in the journal Nature Astronomy, were made after researchers went digging through data collected by the Cassini spacecraft during its tour of the ring planet and its many moons. Back in 2005, Cassini found the first evidence that Enceladus has a hidden ocean beneath its icy surface. Jets of water were bursting out like geysers from cracks close to the moon's south pole, in the process shooting ice grains deep into space. Smaller than grains of sand, some of these tiny pieces of ice fell back onto the moon's surface, while others escaped to form the E-ring around Saturn, which traces Enceladus's orbit. The new data is a clear sign that complex chemical reactions are taking place within Enceladus's global subsurface ocean. Some of these reactions could be part of chains leading to more complex, potentially biologically relevant molecules. Scientists have already found many organic molecules in these ice grains, including precursors for amino acids, the building blocks of proteins essential for life as we know it. But the ice grains in the E-ring can be hundreds of years old, and as they've aged, they may well have been weathered and therefore altered by intense space radiation. So the authors of this study wanted to investigate fresh grains ejected much more recently in order to get a better idea of exactly what's going on in the Enceladian oceans. Fortunately, the authors really already had the data. See, back in 2008, Cassini flew straight through one of these icy geysers. These were pristine grains, ejected only minutes before they hit the spacecraft's cosmic dust analyzer instrument at about 18 kilometers per second. These were not only the freshest ice grains Cassini had ever detected, they're also the fastest. The ice grains contain not just frozen water, but also other molecules, including organics. At lower impact speeds, the ice shatters, and the signal from clusters of water molecules can hide the signal from some organic molecules. But when the ice grains hit fast, water molecules don't cluster, and scientists have a chance to see these previously hidden signals. The authors found that some of the organic molecules that had already been found distributed in the E-ring were also present in the fresh ice grains. So this confirms that they were created within Enceladus's oceans. And they also found totally new molecules that had never been seen before in ice grains from Enceladus. On Earth, these same molecules are involved in chains of chemical reactions that ultimately lead to more complex molecules essential for life as we know it. The authors say there are many possible pathways from these organic molecules found in the Cassini data to potentially create biologically relevant compounds. That enhances the likelihood that this moon could have been habitable. One of the study's authors, Frank Postberg, says these molecules found in the freshly ejected material proves that the complex organic molecules Cassini detected in Saturn's E-ring are not just a product of long exposure to space, but are readily available in the Enceladian ocean. Discoveries from Cassini are valuable for planning a future ESA mission dedicated to Enceladus, and studies for this ambitious mission have already begun. The plan is to fly through the jets, possibly even land on the moon's South Pole Tiger Stripes terrain in order to collect fresh samples. Needless to say, we'll keep an eye on its progress. This is SpaceTime. Still to come, Sierra Space says their Dream Chaser spaceplane is now targeting late next year for its first free-fly demonstration flight. And NASA says its new optical deep space laser communications project has exceeded all its technical goals. All that and more still to come on SpaceTime. Sierra Space say their Dream Chaser spaceplane's now targeting late 2026 for its first free-fly demonstration flight. The test mission will validate critical technologies for NASA. Dream Chaser's unique lifting body design will provide additional cargo carrying capacity on missions to the International Space Station as part of NASA's Commercial Resupply Services contract, which already uses SpaceX Dragon and Northrop Grumman's Cygnus cargo ships to service the orbital outpost. Dream Chaser, which like Dragon is reusable, was originally designed as a manned spacecraft. It'll eventually fly aboard a United Launch Alliance Vulcan Centaur rocket from Pad 41 at the Cape Canaveral Space Force Base in Florida. The first Dream Chaser spaceplane, called Tenacity, arrived at the Kennedy Space Center back in May from the Neil Armstrong Test Facility at the Glenn Research Center in Ohio. When it does finally take off, Dream Chaser, together with its Shooting Star cargo module, will transport some 5,440 kilograms of supplies and cargo on regular missions to the space station. It'll then return to Earth after each mission, landing conventionally on the former Kennedy Space Center Space Shuttle runway, carrying up to 1,750 kilograms of returned experiments and equipment. The idea of a gentler runway landing will allow the return to Earth of more delicate equipment and experiments, which could be damaged in a rougher high-G capsule splashdown. With the early retirement of NASA's Space Shuttle fleet in 2011, Dream Chaser is now the only spacecraft NASA currently funds that's capable of maneuvering within the atmosphere. The Dream Chaser design goes back well over 60 years, with its origins back in 1957 in the United States Air Force X-20 Dinosaur manned spacecraft, which would have been launched aboard a modified Titan III rocket. NASA continued its development in the 1960s and early 70s with a range of experimental spacecraft, including the Northrop M2, the Martin X-23 Prime, the Martin Marietta X-24, and the Northrop HL-10. During the 1990s, NASA used the same basic lifting body design to develop the HL-20, an experimental spaceplane which eventually evolved into the X-38 Emergency Crew Return Vehicle, which would have been an emergency escape pod transported to the International Space Station in the payload bay of the Space Shuttle. It would then be docked to the orbiting outpost until needed. However, that project was canned by NASA in 2002 following budget cuts. Now, NASA have contracted Sierra Space for an initial 7 cargo missions to the orbiting outpost. A second Dream Chaser is currently under construction. Each of the spacecraft will be able to fly at least 15 missions over a 10-year lifespan. A third Dream Chaser was built purely as an engineering demonstrator for ground and flight verification and validation tests. And Sierra Space haven't given up on the idea of a fully manned spacecraft as well. A fully operational manned version of the spaceplane could carry crew into low Earth orbit. And it doesn't end there. The company also plans to use Dream Chaser to launch and build its own orbiting habitat in space before NASA retires the International Space Station in 2030. Now, we mentioned earlier Dream Chaser had a cargo module, the Shooting Star. It's a fully independent spacecraft which can be attached to the spaceplane before launch in order to increase capacity. Shooting Star is fitted with docking ports at each end, allowing it to attach to the rear of Dream Chaser at one end and to the space station at the other. Now, this allows Shooting Star to act as an additional cargo module for astronauts to work in and hold supplies before they're transferred to other areas of the space station. Shooting Star also carries external mounting points for 3 additional cargo containers. But unlike the reusable Dream Chaser, which returns to Earth after each mission, landing on a conventional runway, Shooting Star is designed to burn up during re-entry. Meanwhile, the Pentagon's looking at using the Shooting Star cargo module as the basis for its own autonomous unmanned military space station for research and development, training and operational missions in low Earth orbit. For this, Sierra Space will redesign the module to include guidance, navigation and control systems in order to be able to maintain free flight operations. The military version would host specialized payloads, undertake experimental testing, manufacturing and assembly in microgravity, and carry out a range of logistics operations. Longer-term plans could include high elliptical and even geosynchronous Earth orbits, as well as more distant missions to the Moon. This is SpaceTime. Still to come, NASA's new Deep Space Laser Communications project, and later in the Science Report, a new study shows that people whose dads smoked during puberty appear to age faster than expected. All that and more still to come on SpaceTime. NASA says its new optical deep space laser communications project has exceeded all its technical goals, setting up the foundations for high-speed communications for future manned missions to Mars. The technology successfully showed that data encoded in lasers could be reliably transmitted, received and decoded after travelling millions of kilometres from Earth to a spacecraft at distances comparable to that of Mars. Nearly 2 years after launching aboard NASA's Psyche mission in 2023, the technology demonstrator recently completed its 65th and final pass, sending a laser signal to Psyche and then receiving a return signal from more than 350 million kilometres away. Just a month after its launch, DSOC, the Deep Space Orbital Communications demonstration, proved it could send a signal back to Earth after establishing a link with an optical terminal aboard the Psyche spacecraft. The technology demonstrated data rates comparable with those of broadband internet services, sending engineering and test data from Earth for record-breaking distances. Back in December 2023, the demonstration achieved an historic first by streaming an ultra-high-definition video to Earth from over 30 million kilometres away, about 80 times the distance between the Earth and the Moon. And it was done at the system's maximum bit rate of 267 megabits per second. The project also surpassed optical communications distance records a year later in December 2024 when it downlinked Psyche data from 495 million kilometres away, which is further than the average distance between the Earth and Mars. Managed by NASA's Jet Propulsion Laboratory in Pasadena, California, the experiment consists of a flight laser transceiver mounted on the Psyche spacecraft, along with 2 ground stations to receive and send data from Earth. A powerful 3-kilowatt uplink laser at NASA's Jet Propulsion Laboratory's Table Mountain facility transmitted a laser beacon to Psyche, helping the transceiver determine where to aim the optical communications laser back to Earth. See, the thing you got to remember is that Psyche and the planet Earth are both moving through space at tremendous speeds. They're also so far away from each other that the laser signal can take several minutes to reach its destination, even travelling at the speed of light. The project enlisted the 200-inch telescope at Caltech's Palomar Observatory in San Diego as its primary downlink station, which provided enough light-collecting area to gather the faintest photons. These were then directed to a high-efficiency detector array at the observatory, where the information encoded in the photons could be processed. In another test, data was downlinked to an experimental radio frequency optical hybrid antenna at the Deep Space Network's Goldstone complex near Barstow, California. The antenna was retrofitted with an array of 7 mirrors, totaling 1 metre in diameter, and enabling the antenna to receive both radio frequency and optical signals from Psyche simultaneously. The project also used Caltech's Palomar Observatory and a smaller 1 metre telescope at Table Mountain to receive the same signal from Psyche at the same time. Known as arraying, this is commonly done with radio antennas to better receive weak signals and to build redundancy into the system. This report from NASA TV.
DSOC is the Deep Space Optical Communications Project. It is the first demonstration of using lasers instead of radio waves to transmit data to and from a spacecraft out to distances beyond lunar orbit.
2, 1, engine ignition.
The experiment launched in October 2023 attached to the side of NASA's Psyche spacecraft. And for its first big test, it streamed a cat video.
We got taters!
Yeah, taters! Why was it a cat video? Because the internet loves cats?
Future astronauts are going to need faster broadband-style connections with Earth than is currently available for navigation, health updates, streaming video, and for sending back science. This is the first step in making that possible. So how does it work? Let's zoom in with laser precision to find out. Not far from Los Angeles, JPL's Table Mountain facility plays a big role. The Optical Communications Telescope Laboratory sends a powerful laser beacon over millions of miles to Psyche.
How we've done that is by using 10 separate lasers. So we have 10 lasers that come into the enclosure. We have 10 individual channels, 10 of these collimators, those long clear cylinders. We have a few lenses that then shapes the beam to get it the right size. So by the time it gets to Psyche, millions and millions of kilometers away, it has the right shape.
Think of it as a cosmic game of catch. Table Mountain throws the pitch, Psyche catches it.
Imagine walking outside at night with a laser pointer and try to point it back at Mars. That's the kind of level of accuracy we need to achieve.
And after catching Table Mountain's signal, Psyche used its own laser to send data back to Earth, reaching a record-breaking distance of over 300 million miles. That's more than 3 times the distance between the Earth and the Sun. The Palomar Observatory uses its powerful 200-inch Hale telescope to catch Psyche's laser light, which is now extremely faint after traveling millions of miles.
So by the time the signal from the spacecraft reaches us here at Palomar, it has spread out over the Earth so that the light level is very faint. It's on the single particle of light level called photons. And the way that we send data using these photons is to encode the data in the time of arrival of laser pulses, kind of like sending Morse code using a laser pointer. The light from the telescope gets relayed down onto the optical rail and then into this optical system. The optics then takes the light and focuses it down onto a detector in cryostat, which operates at a temperature just 1 degree above absolute zero. Inside this chamber, there's a detector with a very tiny active area. So we're taking the light from our giant telescope and coupling it down to less than a millimeter.
And tracking a moving spacecraft across the solar system is not easy, but when conditions are right, data flies.
MOS, this is GLR. We're starting to see flashes of light.
DSOC broke records almost immediately after being commissioned. We have established data rate records, giving broadband comparable data rates in the hundreds of megabits per second from Mars close range. That's the first time that anything has been done like this at distances beyond the moon.
The idea here is to slowly start having more optical communications rather than radio frequency communications to just get more data down from space. There's kind of bottlenecks now in just how much volume of data we can get down in a given amount of time from the transmitters that we have.
So we have the downwind signal from Psyche that's 4 watts from 135 million miles away.
One of the things that we hope to do is enable internet around the solar system.
You can send an astronaut to Mars and have them take like a high-def video of the Martian landscape and send that down in like one pass.
A new era of space communications has begun, and it all starts with a beam of light.
And in that report from NASA TV, we heard from DSOC ground software lead Sean Meenum, DSOC ground laser transmitter lead Angela Valesco, DSOC flight laser transceiver lead Kenneth Andrews, DSOC ground detector assembly lead Emma Woolman, and DSOC operations lead Mira Srinivasan. This is SpaceTime. And time now to take another brief look at some of the other stories making news in science this week with a science report. A new study has found that people whose fathers smoked during puberty seem to age faster than expected. A report presented at the European Respiratory Society's Congress found signs of faster biological aging compared to chronological age in people whose dads began smoking at the age of 15 or younger. They found that smoking during puberty creates damage in boys developing sperm cells, and this can be passed on to their children. Quantum computer chips have just cleared a major manufacturing hurdle. A report in the journal Nature claims the University of New South Wales nanotech startup Dirac has shown that its lab-perfect prototype quantum chips can be fabricated under real-world production conditions, maintaining the 99% accuracy needed to make quantum computers viable. Dirac achieved the feat by teaming up with European company IMEC to show that their chips work just as reliably coming off the superconductor chip fabrication line as they do in experimental conditions in a research lab. It's now emerged that around a quarter of all press releases published on major public relations platforms in the United States are probably written by artificial intelligence. The findings, reported in the journal Patents, also shows that science and technology releases were especially likely to be AI-generated. The authors used an AI detection program to estimate the amount of AIs being used to write consumer complaints, job postings and press releases from both corporations and the United Nations. They found that across the board, AI usage had increased from 1.5 to 15% in the 9 months after ChatGPT was released. And it's likely AI is being used even more than the detectors can pick up now. That's because it struggles once AI-generated content has been heavily edited by a human. There's a new warning today about AI agents. These are software programs that act autonomously to achieve user-defined goals by perceiving their environment, making decisions, and taking actions using reasoning, planning, and memory capabilities. Unlike basic chatbots that merely respond to prompts, AI agents are capable of complex, multi-step tasks by dynamically creating workflows, utilizing external tools, and adapting their behavior over time. They function through a continuous loop of understanding the environment, planning the next steps, and executing actions to achieve their objectives with minimal human oversight, leveraging large language models to facilitate this process. AI agents are now being widely used in business. But companies failing to secure them, limiting their access, and knowing what they're doing is causing security risks. Experts are warning that artificial intelligence need to be treated the same way as what you would a real human in terms of access to your computer network. With the details, we're joined by technology editor Alex Zaharov-Reutt from TechAdvice.life.
So I was at a company's conference called Okta. They secure identities, and I've been doing that for 16 years. And they've been doing that so well that they've realized that because of the AI agents that now proliferate across different businesses for customer service or to help employees do aspects of their job in a better way, and there are dozens of these AI agents for marketing and other reasons, but they're sitting on the network and sometimes they get forgotten about, and often they have access to all kinds of data that they shouldn't necessarily be having access to. And often these AI agents can also be hacked. AI wants to be very helpful. And if a hacker can get into an AI agent that is no longer being used and is just sort of sitting there on the network, all sorts of information can be exfiltrated and obtained. And so the need to treat AI agents like they're humans in being able to block and restrict their access and deny access after a certain period of time. And, once somebody has been logged out of a system, be it a human or an AI agent, they get logged out everywhere. This has all become quite paramount. And it's quite funny that in science fiction movies, we see robots wanting to get human rights, and be treated like humans. And here we are in 2025, and we're treating AI agents, which is sort of the least sophisticated form of artificial human you can get, as humans. So it was interesting.
Agents, are we talking about the sort of people who answer the phone when you ring a company? Is that what we're talking about? The sort of electronic, should I say, that answers the phone when you ring a company?
Yes. Look, customer service agents are one form of AI agent, but they're also used for marketing, to create digital content, to analyze business information and data. I mean, an AI agent can be any sort of program that is augmented with the ability to analyze information far faster than a human and then respond and converse with humans in a very human-like way. And
so you could be an AI agent now and I wouldn't know it.
Well, I could be. I mean, part of what they're talking about with death bots is where somebody gathers all the information about themselves before they die, or somebody does it on their behalf after they die. And then you have this virtual version of you that has access to everything you've ever written, every recording that's ever been made about you, or, featuring you on the internet, or that you've uploaded from cassettes and audio and video and CDs and whatever else you've done through your life. And then the AI can simulate you. And there are already people who use these. Well, it is a form of digital immortality. Obviously, it's not you. It's just a simulacrum. It's a fake version of you. But there are people overseas who've used this technology to get closure with, unfortunately, deceased relatives that they couldn't get closure with beforehand. And even though it's all fake, it's sort of, the brain is kind of fooled.
It's comforting.
It's very comforting, yeah. So this ability to have an AI version of yourself, at the moment it's very primitive, but you can imagine in the future when technology is able to almost clone the existing human brain. You will have a digital version of yourself that could then, one day, in theory, be downloaded, whether into a robot or some sort of organic version of you. And even though the real you has departed this earth, if there is an exact copy or a very near copy of you, then do you live forever?
That's Alex Zaharov-Reutt from TechAdvice.life. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies. or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.